Good morning. Let me turn this one off here. Good morning, good morning. Okay, so what we're going to do today is we are going to finish up chapter 7. Can y'all hear me? Okay, good. We are going to finish up chapter 7 with 7.4. And then what I plan to do on Wednesday while we're live is to tell you, get my pen out here, is to tell you everything that's going to be on the test and post it. But what I'm going to do is after today, I'm going to update 7.4. Have y'all been on Canvas recently? Okay, you notice our videos are up there. There's some resources on the same page. Excuse me, the notes are on the same page if I have them available. One of them didn't work out. So that's what I'm going to do after today. Probably right after this class. I'm going to update this video, add the PDF of the notes, put any resources you may need. I'm going to post a discussion, and I think I have decided, I apologize for this, your test is going to be through WebAssign. The reason I want to go through WebAssign is the formatting and the pictures, it's just going to be rough if I go through Canvas. This book did not give me enough resources. A lot of times they'll give me like a resource and a test bank and pictures, so I don't have to recreate every picture like with Paint or Google. So I've decided we're going to do our test on WebAssign. So it'll still be timed and still have a password, but I just want to kind of give you a heads up. Don't go looking for it in the Canvas quizzes like all my other tests have been. We're going to test in WebAssign because I think it's going to be the best format moving forward with our triangles, our unit circles, stuff like that. I will give you like the 120 minutes like I normally give you, which is really just a safeguard for me. If you forget to submit, if you forget to submit, it submits it at the end of the time period, but it should take you about 55 minutes to complete. Okay. I just kind of give ample amount of time, not to cut you off, but to make sure it submits. Like if you click out, it submits at the time limit, but I'm thinking it's going to take you like an hour. I will send scratch paper so I can kind of follow your work, because you can see as you work in this, like sometimes you got to draw it all out. But I did want to give you a heads up on that change that it will be on WebAssign. Okay. So I want to go ahead and kind of jump into this because I know we only have like 40 minutes. We get out at 9:44. I got my sheet of paper to remind me here. So let's just kind of get into this. Anything we don't finish, I'll post up. Robert, Brent, y'all still going to take yours on Thursday? Yeah. Robert, you too? Okay. Other guys, if y'all want to take it on Thursday, that's fine. If you're like, hey, I'm ready, let me just get it done with, that's fine too. But it has to be taken by Friday when you guys leave school. Okay. So make sure you make that happen. If you feel like you're getting sick, maybe you should take it Thursday, because I'm not going to do any makeups or anything like that. Okay. So let's just go ahead and let me move over here. And I want to go ahead and get rolling with 7.4. Okay. All right, can y'all see my screen there? Okay, so what we're going to be doing today is finishing up chapter 7 and looking at some other trig functions. And so, oh my goodness. Okay, just a minute, because that screen drag is going to drive us nuts the whole time. I apologize for that. It seems like it's not one thing, it's another. Sometimes my pen is like a smart board and I have to calibrate the sides of it real quick. All right, let me share this back. Okay, here we go. Nope, it's going to do it to me again. Okay, so what we're going to be looking at is the other trig functions. One day we're going to have a smooth week. One day. Today is not going to be that day. You don't know how much that frustrates me when I can't use that. All right. Is that right side up or is that upside down? Upside down? Is that better? All right. That'd be my luck. Okay. So let's just kind of look at this as we go here. All right. 7.4. The other trig functions. Okay. Y'all see that okay, or I need to zoom in? You're good? All right. So what we're going to be looking at is I want to be able to find the other trig functions and relate them back to sine, cosine, and tangent, the ones we've been working with. So part one, I want to look at finding exact values of the trig functions. And we're going to be looking at secant, cosecant. We'll sort of abbreviate these as well. Tangent and cotangent. So part one, let's just dive deep and let's look at secant. Now, when we're looking at secant, this is related to your cosine, so let me abbreviate it. We use SEC, and we're going to be looking at angle T. If you haven't noticed, your book really likes to use angle T. This is the equivalent of 1 over cosine T, which in relation to thinking about our trig circle, and remember this is a radius of 1. This is x comma y, that order pair that it creates when we create angle T here. Now remember that this is your cosine of T and this is your sine of T. Always remember those. They're kind of alphabetical in relation to your x and y. So always think about it, x and y, that's alphabetical order. Cosine, sine, that's alphabetical order. That's kind of how I keep the sine and cosine straight. So if I'm thinking about secant, that's 1 over cosine. And that means this would be like 1 over your x value. Because we already learned that cosine t is equal to x. So let's move forward. Let's look at part B. Let's look at cotangent. Kind of write it all out there. It is abbreviated as cotangent, C-O-T, of angle T. You'll notice that I kind of do a curled T here because when I start writing cotangent T and then I have maybe a plus sign afterwards, that's a whole lot of crosses going on there. So to figure out if one's my operator, like a plus sign, or my angle T, I kind of keep my T's with a little curve on it. And this is equal to 1 over tangent, like we've learned. So if we relate all this back to cosines and sines, and we relate it to our x's and our y's, let's remember too that tangent is equal to sine over cosine. So if cotangent is equal to 1 over tangent, then that means that, let's see, tangent being sine over cosine, the way I can write cotangent would be to reverse this. And so this would give me cosine on top, sine on bottom. Now the whole reason I want to do that is I want to relate cotangent in relation to my x's and y's. So cosine is equal to x and sine is equal to y. So cotangent is 1 over tangent, is cosine over sine, but cotangent is x over y. Let's do the third one here, cosecant. Now cosecant is abbreviated. We can't abbreviate it as COS, that looks like cosine. So we abbreviate this one with CSC. So cosecant of angle T is equal to 1 over sine. And we know sine is equal to y. So 1 over y. So I wanted to look at these three trig functions, relate them back to our unit circle, relate them back to that x comma y. You are going to have to work with the unit circle and at some point complete the entire unit circle for me, getting all the angles, all the quadrants, all the radians, all the ordered pairs. And that's very beneficial as you move through this class and other classes if you need them in order to work problems more efficiently. So part D, let's look at examples that we can work with this. So first, let's look at what is given. So we're going to draw a nice little picture here. Say, here's my unit circle. Say I have this angle coming over here, and this is my angle T. And this point right here is negative square root of 3 over 2, comma 1/2. Okay, so this is all given. The picture is given. The ordered pair is given. We can see that it's lying on the unit circle. And the question says to find all 6 trig functions. Find all 6 trig functions. So that means I need to find sine, cosine, tangent, cotangent, cosecant, secant, and figure out what all they are, just given this bit of information. So this is not a problem where if it was given on a test where you go, not enough information given, you have enough information based off this ordered pair and this angle in order to figure this out. And so I'm going to kind of slowly start. I want to start with the first 3 trig functions, and then we know we can manipulate and find the other 3 from there. So the first thing I want to look for is my cosine t and my sine t, because I feel like everything else is going to fall off those 2 things we can see from the top of this paper. Okay, now also remember that these are alphabetical, so there's C and there's S. So what is my cosine of t? Negative square root of 3 over 2. Now, if you don't know that that ordered pair on the unit circle also relates to the cosine and sine of the angle, then you're going to be lost with the whole problem. If you know that thing, this whole problem is just a matter of writing it down, and there's not a really a lot of like grinding it out work to go with this. Now, what is sine of t? Sine of t is just 1/2. Again, reading the given information, taking what I know, and answering this question. Now, the next one I want to find after this is tangent. Because remember, tangent t is equal to sine over cosine. Well, sine over cosine means I'm going to take my sine and divide it by my cosine. So I'm going to have 1/2 divided by a negative square root of 3 over 2. And don't you dare tell me you're done with that answer. That was a fraction, and then a fraction, and another fraction. So you're going to have to do your arithmetic with this. Now remember, when you're dividing fractions, you keep it, change it, flip it, or you multiply by the reciprocal. So I'm going to keep the first, change it to multiplication, and flip the one on bottom. When I go to multiply fractions, I multiply the tops, I multiply the bottoms. It gives me, see those 2's cancel, so 1 over negative square root of 3. Now, not only did you have to remember how to divide fractions and multiply fractions, essentially, you also need to remember your radicals. We don't ever leave the radical in the bottom, so we got to rationalize the radical. When I rationalize the radical, I multiply both the top and bottom. Can I get us going here? By the square root of 3. And so my final answer would this be square root of 3 over negative 3. So follow your rules like you've learned in algebra along the way. Make sure you don't leave the radical in the bottom, and also make sure that you finish out division of these fractions. But other than forgetting maybe some details of algebra, this isn't bad. Okay. Now that being said, so we've got cosine, we've got sine, we've got tangent. Let's look at cotangent next. Now, when I think about cotangent, I think about this, I'm like, okay, cotangent is 1 over tangent. And it's also equal to cosine over sine. So let's see, wasn't this one just be negative square root of 3? Because if you remember, before I rationalized that radical, tangent was 1 over negative square root of 3 before I rationalized it, right? So cotangent is its reciprocal, so it's just negative square root of 3. Now, you could have taken a different approach to that, by all means, but to me, that was the quickest approach to it. Let me zoom in a little bit. Okay, so I've now got cotangent. Let's look at cosecant. Now, cosecant is 1 over sine. So that means I'm going to have 1 over my sine is 1/2. You can see why we start with sine and cosine before I dive into the other 4. And so that reduces out to positive 2. Do not leave 1 over 1/2. Please simplify up as much as possible. And then our last one is secant. Well, secant is equal to 1 over cosine. So that means I'm looking at 1 over negative square root of 3 over 2. So that gives me 2 over negative square root of 3. Rationalize out that radical. And so then this gives me negative 2 square roots of 3 over 3. So again, finding all 6 trig functions is not very in-depth, like in the trenches, like some of the other work that you may have done in your math classes. But once you get your sine and cosine, it's just kind of multiplying, dividing with those fractions. Make sure you're rationalizing out the radical in the bottom. So let's do another one here. Number 2. And it says find all 6 trig functions, or it says actually find sine, cosine, tangent, secant, cosecant, and cotangent when t is equal to pi over 6. And that's all they gave you. So you'll see as we move through this course, a picture is so important. And so let me draw it. Okay, pi over 6 is in quadrant 1. And so just kind of a rough sketch here. I'm going to call this my t, and this is equal to pi over 6. In relation to my unit circle, we've done this triangle. We've done pi over 6 in previous notes. So this ordered pair right here is square root of 3 over 2, comma 1/2. Because isn't pi over 6 30 degrees? And if you watched 7.3, we worked with how to figure out the 30, 60, 90 triangle and how to figure out its ordered pair and how it's related back to the hypotenuse being double the short side. You remember all this conversation? And so when we're looking at this one, I already know this, and there's previous proof and previous lectures. So now, if I want to find all 6 trig functions, I'm going to start with sine and cosine. So I'm going to say sine of pi over 6. Cosine of pi over 6, tangent of pi over 6. I'm going to find these 3 first, starting with sine and cosine. Then I'm going to also make sure to find cosecant of pi over 6, secant of pi over 6, cotangent of pi over 6. And I kind of like to make my list and also line them up according to it, like which one are reciprocals of the other. That's not necessary. It's just kind of my organization here. Because if I look at sine, remember, here's your cosine, here's your sine. If I look at sine of pi over 6, that's 1/2. Well, cosecant is its reciprocal, so it's 2. I'm 30% done with this problem here. Cosine, given by what I know about pi over 6 and the unit circle, is square root of 3 over 2. So secant is 1 over cosine. So that means this one would be 2 over square roots of 3. And just further up on this page, we already discovered that that's 2 square roots of 3 over 3. More than halfway done now. Now, tangent is sine over cosine, and you can kind of work with that. And this one would give us, we've already done it in the previous problem, square root of 3 over 3. Because talk about this angle in relation to the angle that we just identified here from the previous page. This angle here had the same ordered pairs, but it was in quadrant 2. So because the unit circle is reflective, you're going to see that these have the same ordered pairs. So their trig functions are very similar. And so tangent is going to be the same work as we saw here. Sine over cosine, 1/2 over square root of 3 over 2, square root of 3 over 3. But we're in quadrant 1, so there's no need for the negative. That's why I'm kind of jumping into this answer, because we just worked this. Do you see that? And so then we can also get cotangent, and cotangent of this one ends up being square root of 3. Now, so I wanted to do a couple of angles, and I wanted to be able to find all 6 trig functions, because this will come up on an exam of given an angle, and it can be different information that's given. It could just, like this one, have been given where you have pi over 6. It could have been given where in the previous one, I actually gave you a picture to go with it. So part 2, what we need to look at is simplifying trig expressions. Simplifying trig expressions. And so I just want to kind of jump in here and start looking at some examples. Here's how it would be given. Simplify secant t over tangent of angle t. And so you can see that no angles are given, no picture is given, no ordered pair is given. This is just the case where I need to simplify up and kind of use some identities and kind of properties to go from here. So I'm going to tell you, I really like working with trig because it's almost like a puzzle sometimes to figure out. Think about what you know, how you can manipulate, maybe do little small steps along the way. And so what I'm going to do is I'm going to say, okay, secant and tangent. I really don't know how to simplify straight from the step of secant and tangent. But I've learned that outside of sine and cosine, all the other trig functions work, right? Kind of like colors. There's really only like 3 basic colors, and they combine them all in different ways in order to get the other colors. You know what I'm talking about? Like red, yellow, blue, and you put red and blue together and you get purple. And you put red and yellow together and you get orange. But if you go down to the basis of it, it's all variations of red, yellow, blue. You with me? So trig functions, they're all basic levels of your sine and cosines when we're talking about the 6. And so I can't relate directly secant and tangent. But maybe if I took them down to their basics of sines and cosines, I could simplify up and relate them and maybe cancel something along the way. And so if I'm looking at secant, this is 1 over cosine. I'm not sure where I'm going with this, but I'm thinking if I could go to the sines and cosines, I could break it down from there. Tangent is sine over cosine. So I'm already a little bit encouraged because I'm seeing some similarities. Maybe I can cancel something out. I've got a fraction divided by a fraction, so I'm going to kind of write that out more horizontally. This would be 1 over cosine. Keep it, change it, flip it. So keep the first, change it to multiplication, and flip the second. So divide these fractions out. Now I can see some things going on here. These cosines are going to cancel each other to give me 1 over sine t. And although I've canceled out the cosines, I really don't want to even stop with 1 over sine t. Going back to the basics helped me to identify kind of more that I could do with the problem, but in the end game, I need to simplify up and revert back to whatever I can. And 1 over sine t is equivalent to cosecant. So the instruction said, simplify secant tangent. Answer is cosecant tangent. These steps are neat along the way in order to show your work. So kind of neat there. This is why I try to make sure students are not calculator dependent, because that's not a calculator problem. And so you kind of run into steps like that. So I kind of help them to become not so dependent as they move through courses for situations such as this. Okay, let's do another one. And it says simplify tangent cosine. And that's all they gave you. And so again, I'm going to take it down to basic levels, see if anything arithmetic-wise can happen there, any reductions, any simplification, and then figure out what I can go from there. So I know that this thing is equal to tangent is the same thing as sine over cosine. So that's looking to be pretty beneficial. And cosine is just cosine. So this is just multiplying two fractions. My cosines end up canceling. So it gives me a final answer of sine t. So I really love these simplifying expressions because I think it really has you work with the basic building blocks of each of these trig functions and see what are your possibilities on how to simplify them. So if you're faced with harder problems that has coefficients and numeric values and more to it, you know a tool or process to kind of help you get there. Okay. That all being said, part 3 here. We've already looked at the Pythagorean identity. When we were trying to figure out all the different parts of our unit circle, we looked at some of those there. But I want to emphasize some of those that are related to that. So part 3, I'm going to say alternate forms of the Pythagorean identity. Alternate forms of the Pythagorean identity. Now, we've already seen when we were manipulating and working around with figuring out all the ordered pairs on our unit circle, we already saw the cosine and sine one, but other ways that we can relate it, and it all goes back to some of these simplifying, is you have 1 plus tangent squared t is equal to secant squared. That's another Pythagorean identity that we can pull out. It's just an alternate form. Or we can relate it to cotangent. Cotangent squared plus 1 is equal to cosecant squared. You can see why I do kind of a curled T here. Look at all these plus signs up, and there's even some ones. Throw in if you worked with a pencil or a pen that dragged, how that could be a problem. Now this comes from page 627 if you would like to see a proof of how these are derived from your Pythagorean identity with your cosines and your sines. But I want to go ahead and write those, emphasize those, and just depending on what you're simplifying and what you need, maybe your problem has a bunch of tangents in it and a random secant squared. You could use this substitution for your secant squared. Maybe you're working with something and it's division, and it's working with like cotangent squared plus 1 is what you end up in your numerator. You could work it to cosecant squared and maybe you further manipulate or simplify. And so these identities all have their place in time where they are needed. And so I just want to kind of throw that in there. Now, let's do this. Let's do some more examples. Some more examples as we go. Here's number 1. Say cosine t was equal to 12 over 13. And t is in quadrant 4. Find the other 5 functions. Find the other 5 functions. Okay, so what I want to do is, this is all that is given. No picture is given. That's why it's so important to have scratch work and kind of draw out what you know. So I'm going to go ahead and draw my coordinate plane. It says that it's in quadrant 4, so I'm reminded that here's quadrant 4, 1, 2, 3, 4. So that means this angle is going to be dropped down here, so there's angle T. And it tells me that cosine is 12 over 13. So that means that if I were to draw this in relation to this unit circle here, this ordered pair right here, its x value would be 12 over 13 because cosine sine. So if that's the x value, that tells me that this side length here is equal to 12 over 13. It's on the unit circle, which has a radius of 1. So because of its quadrant, its cosine, it's on the unit circle, I now have two of the three sides of a triangle. So I need to figure out this y value, because we've already seen if I can get my cosine and sine, everything else falls out. So the first thing I'm going to do is I'm going to find sine. I need to find y. If I want to find y, I know that I can just solve my triangle here. This is a 90-degree triangle. So I'm going to take this back and I'm going to do Pythagorean theorem to it. So I'm going to say x squared plus y squared is equal to 1 squared, because we're on the unit circle. My x squared is 12 over 13 plus y squared equal to 1 squared. 12 over 13 is 144 over 169. Solve for y, so I'm going to subtract this over. I get y squared equal to 1 minus this, so that gives me 25 over 169 and square root. So y equals plus or minus 5 over 13. So when I square root, I do get two answers. I get that plus or minus, but I already know that we're in the fourth quadrant. My y values down here are negative, and so negative 5 over 13 is what I'm going to be using. Alternatively, if you were to look at this, you could use your Pythagorean identity in relation to sines and cosines also to solve this. So I want to show you that real quick. So you say cosine squared plus sine squared equals to 1. Well, cosine squared plus sine squared equal to 1. Notice it's similar. So that means I get 144 over 169 plus sine squared equal to 1. Subtract it over. I get sine squared equal to 25 over 169, just like here. Square root. So I get sine t is equal to plus or minus 5 over 13. But again, we know that we're in that fourth quadrant, so the negative is the answer we want. So all the same steps are following suit. So I just want to kind of show you this alternative way you could have approached this. So that being said, we know cosine. So sine is equal to negative 5 over 13. So that means tangent, we can now find it, is sine over cosine, sine over cosine. So see, that would be sine times, flip this one. So negative 5 over 12 for tangent. Once I have sine, cosine, and now even tangent, all the other ones are kind of going to follow suit. And so let's see, secant is equal to 1 over cosine. So cosine was 12 over 13. That means secant is going to be equal to 13 over 12. Cosecant is 1 over sine. Let's see, sine was negative 5 over 13, so this gives me negative 13 over 5. Cotangent is 1 over tangent. Let's see, tangent was negative 5 over 12. And so this gives me negative 12 over 5. And so you can see these three fell out really nicely as we work through this. Okay, so as you're working through this section, you're going to see more of definitely less calculator in your life, use of your unit circle, use of your x and y values on your unit circle, and deriving all 6 trig functions, or possibly simplifying up trig functions based off what you already know. So this kind of finishes up chapter 7 for you. I will post some information about the chapter 7 review, some references, some ideas of what to expect on the test, and I'll place all of this within Canvas. As always, if you have any questions as you're working through this, feel free to send me a Canvas message and ask along the way. All homework will be due the night before the exam, so make sure you get that completed in enough time and ask questions in enough time. So I hope this helps finish up chapter 7, and I will see you guys next time.